Finding the inverse of a function is really not a whole lot of steps to remember. We just switch x and y and then solve for the new y, whatever that is. Now, sometimes solving for y is hard, right? This step can be tricky, but let's see how it works for this problem. I'm going to take this equation over here that we're using and just bring that down over here so we can work on it. And instead of saying f of x, I'm just going to say y. So y equals e to the 3x plus 7 minus 1. Excuse me, I wrote that a little wrong. Let's try that again. E to the 3x plus 7 minus 1. And let's just change. There we go. So what I'm going to do now is switch x and y. So this will be x to the, let me just read what I'm writing. Don't listen to what I'm saying. X equals e to the 3y plus 7 minus 1. Now to get y by itself, you have to remember that when you have a variable in the exponent, you're going to need logarithms. And first step we're going to do is to isolate the exponential. So it looks more like this. And now we take the logarithm of both sides. I'll use the natural log because that makes it easier to cancel things out. So I'm going to take the natural log of e to the 3y plus 7. We'll see that canceling happen in a moment. A lot of people are just used to saying, hey, natural log of e, yay, it cancels out. But let's just take a moment and go over that step in a little more detail, just so we're all on the same page here. You have natural log of x plus 1, and that's equal to, using the power function, let's go through this in detail here, we're going to take that exponent and bring it down in front. That's how the power rule of logarithms works. So we do 3y plus 7, that's my exponent, and what's left over is natural log of e. And this is what's equal to 1, so it cancels out. Now that's pretty nice. If we just subtract 7 from both sides, you'll see that I'm nearly there. And now we just need to divide by 3. So I got natural log of x plus 1 minus 7 all divided by 3 equals y. That is our inverse function. That was the goal here. So this is our answer. You can take this and put this over in this box up here where it's asking you what is the inverse and so on. So I'm going to say the inverse is the natural log of x plus 1 minus 7 all divided by 3. Okay, so that's the major part of this problem. The next part is not as big a deal. We're just going to figure out what the domain is. And for that, I just want to remind you how domain works. Whenever we talk about domain, you should always be thinking of domain restrictions. And in particular, exponential functions have no domain restrictions. In other words, there is no value of x where if you plug it into that exponential equation, it's going to get you in trouble. Whatever x is, it's going to be fine. You can try a calculator if you like, just to see if that's true. But an exponential function always has the full range of real numbers as its domain. Logarithms are different. For logarithms, let's see, how can I phrase this? Can't log anything less than or equal to 0. Okay, that's not allowed. Any argument which is 0 or negative is going to get you into hot water with a logarithm. So what that means is our argument here, which is x plus 1, must be greater than 0. What that means is x has to be greater than negative 1. So if I want to write that in my domain, I would phrase it this way. Negative 1 is the smallest it can be, but not actually quite negative 1, just a little above it. Anything from negative 1 to infinity. Those are my allowed domain values. Now, the next part is quite easy. All we need to do is remember that inverses switch like this. So the domain of one is the range of the other, and vice versa. So we can just take those and swap them back and forth like that. And we are done with this problem.